hosts, and welcome to another live stream of me working on code. Today I am going to be working on Project In Between, or Project Tween. In this part, I am going to be processing looking into processing the boundaries into shapes. Let's jump into that and I'll explain what we're doing. So on the right, we currently have our shape key code, which we probably want to expand at some point, which has some concepts of shapes, but there are a whole lot of different types of shapes here, and we want to have these become a singular shape. So what we are going to do is have this structure here, which is going to be basically creating the concept of a shape. Right. And we're going to basically represent all these shapes as loops of Bezier curves. So each shape is an island. We've got boundaries there. How did I do? I'm going to go path, path, boundary, boundary. Okay. So this goes anchor, handle, actually it's going to be path. Ooh. Can we go past boundary? Boundary, is that? So because we're doing Bezier curves, we've got to alternate between the anchor points and the handle points. Yeah, that makes sense. Let's see if that compiles. So let's load it up. No, it doesn't. So go call this handle anchor. Actually, we'll call it a control. Control. control, say path followed by a boundary. Control. So anchor handle. Cool. Right. That makes a bit of sense. So how does that work? Find but not used. Yeah, the so we can export all of these points. Path. Shapes. Control. And 3. Right. Control. Oh, control. Control. All done. Excellent. Okay, 3 modules loaded. Cool. Biome tree. We don't. There we go. Cleared up some things. Let's see how we can have this compile. So what we are going to now use is port shape tree as ST. Why does that say ambiguous when I think we got to go Haskell import qualified? Okay, yep. Port qualified ST. That should fix up the collision problems. And it says it's redundant. That's a nasty message. It says it's redundant. Oh, it says redundant because we're not using them yet. Okay, that's fine. Okay. Render. We're going to take in we're going to create a type class just to make this all right. How do we do type classes again in Haskell? Haskell type class. Where are we? Type class. What's the introduction? Here's where I'm reading from. Type classes and overloading. Class, blah, 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 where, blah, 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 blah. Okay. So, class render. Sorry. A where do I want to do it this way? No. Okay. Take that away. Realize that doesn't make any sense. We'll keep it at one step at a time. So we render ST shapes into shapes. Right. So far, so good. Render equals undefined. Export render. Going well. Let's deal with the easiest one first, I guess. Which is going to be the outline. Render line. So it's biome. Oh no, so it's closed path because that's path, which is biome and path. And that's going to go st dot closed path. Find but not used. Yep, that's fair. So we are transforming a closed path in one aspect into a closed path in another. That is fine. So this will be have to be an edge. Oh. This is getting complicated. Because this one then has multiple components to it. So we're going to have to do a case. Case of let's have a look. Let's just write down our thoughts. This is perhaps the simplest case, a shape defined by handles. So it is a conversion between splines. Case path of. So we have line, point, line, point, path prime. So point is the handle. And we are going to be rendering that thing we want out of this. So shapes, structure, and actually a boundary. Oh, for this, that's a good point. That might not be defined. Maybe. Right, so we say shapes that. Hold on. Actually, let's do the really simple one. Render st bg biome. Which is shapes empty that and just biome. Comment that out. Comment that out. Save. Load. Yep. Cool. One thing done. Okay. Render ground. Just set the biome to the appropriate you. Okay. So, closed path is so what we do is we call this, we change it into from a line into a curve. So we go render st dot closed path curve point point path. That's no. Okay, I'm gonna put a note here. This case is wrong as the end control points should be doubled as well. Fix me. How would we fix me? Point path, curve point. Ooh. Also, when we're recursing through the line, you actually got to recurse. We've got to keep track of that. Okay. I'm going to call this render closed path. Of course, I've realized I'm going to have to take care of the matter of the endpoints. So path. Actually, we can do that just as a okay. Render path. Oh. Let's actually split render path out. Because we have special cases here. Render path equals the path biome start path path. Okay. So you take BT node 4, zoom, a BT path and a BT path. And you return shapes. Render path. Equals undefined. I love making things equal to undefined. It's a great way of doing stuff. Just does. Oh, st path, st path. That's better. Oh, and arrow. Thank you, Mr. Curry. Yep. There we go. So, closed path. We have biome, line, which has a point, and a path. And a start. That's going to create more errors, isn't it? Yeah. Ah, it's an ST line. Lane. Yep. Right. Spines. We make use of the render path function so we can keep track of the start point. So it makes more sense for the start point to be over like that. Yep. All right. So we want to look at the next point. Say it's the same as the previous point. So we've got to extract the point from the path, but we can't do that because we can have a handle to a curve. Oh no, that's fine. Right. So case path of line and point that point doesn't matter. Sorry, so like that. Let's check the case statements in Haskell. Haskell case of example. Let's have a look. Lazy pattern, lexical scoping, let where cases. Oh, hold on, let's search for case of. Case, blah, blah, blah. It is a right arrow, okay? Line endpoint. We go. Render path like that. Biome. That's the start point. Oh, okay. So start. We simplify it to an ST curve. We go point, point. And then we go endpoint, endpoint from point, point. And I've realized that's wrong. Hold on. Oh, no, it's not. That's fine. Endpoint, endpoint. Because we're trying to emulate that. But then how do I get the rest of the... Oh, right. Endpoint. And the rest of it would be path. So that should emulate a line. Actually, not path, but... And I don't have to render that in because the rendering of that will be taken by the next recursive step. There we go. Yes, I follow that guy. Okay, let's be ST line. The line endpoint. Gonna get more errors there. Warning, incomplete patterns. Yep. So we go ST curve. Which paradoxically, no, which is, okay, so start, encore, start, handle, end, core, end, end handle, and core. And now this gets to the bit which is going to be more complicated. So I'm going to avoid it. Hold on. Oh, this is just rendering the line. Hold on. Oh, yeah, we're still in rendering line territory. So, curve. This is another one where we are converting it to a thing. So this is just us extracting the line and recasting it as a ST curve. So got to keep that in mind every time we do this. So for this, we only actually need the start anchor. There. Point. Start anchor. Start. Point. Start anchor. Path. ST end point. Would help if we lined all these up, make it nice and neat. Like that. Let's go to line depth. Render path biome. Let's put a comment here. For the case of a line, convert all straight lines to Bezier curves. Start T dot curve point end point end point. Well, that's nice. And closed. Don't need to put brackets around that. I'm not sure if we need brackets around the other ones either, but we'll try stripping the brackets off a little bit later. Render path. And start. Curve. Point. We've got to break out the have to actually go render port, blah, blah, blah. Line. How do we deal with the start? Do we say maybe start? Because otherwise things will loop around forever. Just thinking about how we're going to deal with the closed situation. We don't want to have it be looping. Or do we care about that? Because we're using a lazy language. No, it probably... Let's go. Patch. What am I? Just trying to think about how to solve this particular case, because closed means it's a reference to the first element. So I just want to convert it back into a line that's going to the first element. But I just don't want to have the rendering path continue beyond that. Which I was thinking I could signal by just not passing the start in. But that sound feels ugly. We'll solve it in an ugly way first, and then deal with de-uglifying it later. Point rather than go. Nothing there. Point. So you do maybe? No, we can't. Or maybe we just do that. So we go point. To start st line. So that's the first point of the line. Point. And just a line to the end. Okay. This is the start. Right. Okay. ST closed. Yeah. That's better. Right. ST curve should have 4 arguments, but be given 2. ST curve. Point path. So start anchor. Three. That's better. It went blunk. Not sure. Did I say maybe? Okay. Maybe off. Start path there. End point. Fourth argument of the curve, endpoint. That's right. That should be path. They're all paths. Yep. Right. Non-exclusive. Flunk 40 in shape. Hey. ST line. Oh, we've got that done. For the case, a curve. What do we do? Render path, biome, start, ST, curve. So we've got start, anchor, start, handle, end, handle, path, equals undefined. All right. So we want to define these in terms of the structures we've already got. So we want to create a shapes. Of some description. All right. This is going to be a single boundary. And we don't have a biome defined for this, so it's think where boundary equals undefined. So the trick of the complex problem is to break it down into simpler ones. So a boundary is this going to, by definition, we don't know if it's a closed path or an open path. To determine which shape to use. Although outside extents of a shape Hi, Slim. Good to see you. How do we get... Okay. Boundary, the outside extents of a shape. So that will have to become a closed path. Hold on, no. We've got boundary, and we've got to render path gets called from closed path, so we'll always have st closed here. Okay. That is a fine. How does the programming go? Pretty good. Just a little bit overwhelmed at the moment by the complexity, but we are slowly sort of chinking away at it, or plinking away at it. All right. So this is ST curves. Let's go case. We do have to do a case path just to decide what to do. Path of st align point like that. So boundary is going to be edge path right. So what's the type of start anchor in this case? Is of st curve. It's a point. So that's going to have to convert a point. Right. Going to have new thing, render point. That's going to take in a st dot point and return a one of these paths. So it's going to take in a point and return a native path. But we'll work out how that's done later. Point equals the I love being able to say something equals undefined. There. So we go edge. Where are we? What wants through edge? Path. Render point. Start core. Render point. Start handle. Render point end handle. That's get things lined up. Take a little sip. There we go. Right. Then render point and point, and that looks wrong. Okay, so edges need a control. So edge, blah, blah, blah. Control. Gonna sneeze again. Excuse me. Okay. Just working out how this works. So control. That's the handle of the controls point. And oh, okay. So render path should be rendering to a ooh. Just what am I missing? Shapes boundary determ. I think we have to fork this off and make this into another separate submodule just to render boundaries, maybe? doesn't feel right. Because this has to recurse. So, control. Oh, it takes... What's a boundary, not a... Ah, okay, I get it. I say, or I might not get it at all. Let's add a thing. See how the Haskell let statement goes. Haskell let in. Where bed. Let stare. Okay. Right. Let what do we call this thing? All right, I'm gonna have to decompose it first. Shapes. And BS equals point, and that's going to be render path, that biome start. The next step along, so path. In. Like that. Point there. Edge, path. Here's controller which recurs. My brain is overheating. Think we will leave this for the time being, because we've done our hour's work on it for the stream, and we've got some other projects that are in the background. So we'll look into those later. I'll just... because that's one of the key insights about programming. If something's too complex, stop working on it and work on other things and let your subconscious think about it. Let's get back to our main room. Thank you, everybody, as you watched me work on this part of Project Tween. We are currently doing the code to render the shape code into Bezier curve code, so that's slowly progressing. We knocked out straight lines at least, and we're now handling the much more complicated curved curve transformation. So that is coming along. Thank you, everybody, for joining me, and I hope you'll be well. Thank you, and see you later. Goodbye.